further ado, I would like to introduce from Aireon, Mr. Don Thoma, and from FlightAware, Mr. Daniel Baker.
Well, thank you everyone for taking the time to join us today and learn a little bit about a new capability that we're introducing that we think will help solve some of the issues involved with global flight tracking. Myself and my colleague Daniel Baker from FlightAware will provide you a little bit of an overview of some of the background and the genesis of this capability, a little bit about the infrastructure that is being deployed that will enable the capability for global flight tracking, and then some of the tools that we'll be providing that will support the provision of this capability to the airlines around the world. A lot of people in the general public don't realize that the majority of the world's airspace is not being surveilled. We fly to Montreal or fly to Europe or Asia looking at the seat back in front of us and the map on it and find out that and think that we're being tracked, that people know where we are. What the aviation community, and certainly the aviation community that operates in remote environments know, is that it's really just the pilot that knows where he is, and maybe you are if you're looking at the map. But that data is not being provided in real time back to air traffic control or search and rescue authorities, or anyone but people on the airplane. So that creates a lot of challenges in the air traffic management environment, and certainly in the search and rescue environment. Unfortunately, due to the tragic events of MH370, it was highlighted the need for better capabilities. The questions that kept being raised by the public, the flying public, is why can we track our phones, track our kids, our cars, but not be able to track aircraft? A very expensive piece of equipment, and even more expensive and valuable lives on board. ICAO took quick action and convened a special group to address this specific issue, and out of that was formed the Global Aeronautical Distress and Safety System, or Gadis, which is currently being worked through the various ICAO committees to make some very important recommendations to the aviation industry to support and address this issue. And primarily, in November of 2018, will require that all airlines operating outside of surveillance to be able to report back their position on a 15-minute interval or less. And then secondly, in January of 2020, a recommendation that will require the ability to track aircraft on a 1-minute interval when they move into a distress mode. So these two actions in themselves are a very important aspect of improving this capability and making sure that events like MH370 don't happen again. Obviously, there's many requirements that are currently being addressed and reviewed and will be soon published associated with this. Some of them are known, some of them are in work. As I mentioned, the very specific requirement of allowing aircraft to report back their position once a minute or once every 15 minutes in a normal operating mode is important. The second area that's being assessed is how do you create the ability to identify a distress situation and send that information back to the appropriate authorities in the event of that occurring. A lot of discussion still to go, though, on what creates a distress situation, how do you monitor that, what triggers the notification of that. And once that occurs, the thought would be to send and transmit an update on at least a once-a-minute interval from the aircraft back to the operator. Obviously, out of that comes a lot of additional discussion, which will have to ensue over the next several years of how is that information then relayed to the appropriate authorities that can intervene and perform important functions like search and rescue in the event of a distress, and then how do you cover this in areas that are outside of the airlines or the air navigation service providers area of operation or coverage. As we all know as aviation professionals, there are a lot of challenges operating in a remote environment and in the ability to address some of the areas that are being encompassed by the Gadis recommendations. As we all know, certain infrastructure for surveillance has issues associated with line of sight, typically terrestrial-based surveillance such as radars or ground-based ADS-B or multilateration are limited to roughly 200 to 250 miles from the location of the ground-based tower. Of course, there's other issues. We know that this can be accomplished with satellite communications. However, there are certain issues with SATCOM and satellite voice communications, including the low equipage levels. Even though majority of the wide-body aircraft are equipped with SATCOM, there are a significant number of aircraft that operate in remote and oceanic environments that are narrow bodies or older equipment that don't have SATCOM, but in discussions with airlines, most likely will never equip with SATCOM due to the cost and complexity of upgrading the avionics on board. There are certain issues as well, even with SATCOM, about providing full continuous coverage over all of the remote areas, including the polar regions. There's only a few areas that can be, or a few systems that can cover that capability, as well as I mentioned, the ease of implementation, the ability to create standards and the ability to meet those standards in a way that harmonizes the use not only of the equipment but also procedures across multiple airspace. So there's clearly a lot of challenges that still need to be addressed in the implementation of the Gadis requirements, but certainly in a complete comprehensive way, there are ways to address all of those issues that I believe the groups addressing Gadis will certainly identify. One of the enabling capabilities that will be deployed over the next year and a half to be in full operations by 2018 is a capability called space-based or satellite-based ADS-B. As you know, automatic dependent surveillance broadcast, or ADS-B, is the next generation surveillance technology. It's being implemented by many air navigation service providers around the world, in the US, in Australia, in Canada, Singapore. There are a number of mandates, including those countries as well as Europe, that are requiring or providing incentives for airlines and aircraft to equip with ADS-B. And the key elements of ADS-B that make it really the future of air traffic surveillance are the fact it uses GPS, very accurate, precise location information, and transmits that information over a radio signal to towers or in the future to satellites on a very frequent basis. The system that is being deployed by Aireon is a satellite-based network that will ride on top of the 66 satellites that are being deployed by Iridium. It's unique in that it provides full 100% coverage. As you can see from the illustration, the satellites orbit over the poles, so there's no place on Earth that isn't covered by that will not be covered by the Aireon system. And the fact that each of those satellites communicates with all the satellites around it enables for the real-time transmission of that data from the aircraft to the controllers or automation systems in near real time, less than two second latency on a system such as this. So it really is a unique capability that will help form part of the solution to addressing the needs of global normal tracking as well as distress tracking in the future. The system is being deployed primarily for air traffic surveillance to provide real-time location and information on aircraft for air traffic control purposes. The plans are to use it in at least 3 operating environments. One, as you would expect, in remote regions such as the oceans, where it will be the only source of surveillance for operations in those oceans. But equally, it's being evaluated for use in both terrestrial areas where there are multiple forms of surveillance, but gaps in coverage or gaps in surveillance, but also as a backup capability where there already exists surveillance. So this would provide a very cost-effective way for contingency purposes to back up that existing surveillance. And the primary purpose is to improve safety and efficiency of the airspace that uses this capability. The system itself is being developed and deployed by a set of stakeholders that are very familiar with the aviation industry. The air navigation service providers of Canada, Italy, Ireland, and Denmark, as well as the satellite operator Iridium, are the primary investors in the program and are guiding the deployment of this service to begin its capabilities in the North Atlantic in early 2018. So it's, as we like to say, it's a service that is developed by people who really understand the needs of aviation, the needs of aviation surveillance in remote areas, and providing the capabilities and support in deploying this in a way that will support all of the aviation industry on a global basis. So with that background of both Gadis and of the capability for space-based ADS-B, I'd like to turn it over to my colleague now, Daniel Baker from FlightAware, to talk a little bit about a new capability that we've joined together to provide called Global Beacon, which will provide a global flight tracking capability to support the upcoming Gadis requirements. Daniel?
Thank you. Thank you, Don, for that that introduction, as well as ICAO and everyone who's able to make some time to learn about what we're doing. I'm the founder and CEO of FlightAware. FlightAware is a company based in Houston, Texas, that provides flight tracking and flight data solutions to both aircraft operators around the world. We have hundreds of customers totaling about 10,000 aircraft using our system for flight tracking, both for safety and for efficiency, flight planning, scheduling, all of those operational tasks, as well as for consumers. So we have a free website and mobile apps that are used by over 12 million people around the world in over a dozen languages. And people can use that for tracking their own flights or flights of friends and family. I got into this service as a software developer and also a commercial pilot who saw that there was a lot of need for more information about airplanes' whereabouts and more transparency rather than very simple flight status that shows a flight's taken off and perhaps the estimated position. And the way that we've achieved that is we've partnered with ANSPs in about 50 countries around the world to receive their real-time data, whether it be flight plans, flight plan amendments, departure and arrival times, reroutes, radar ADS-B, transoceanic surveillance. And we fuse that all together and provide it both in web interfaces and data feeds and in applications. And so we're very excited to partner with Aireon at a time when this technology is clearly in great demand and in need by airlines as well as by ANSPs and regulators to be able to leverage this technology that we've been working on for many years with the technology that Aireon has been putting together for several years and provide that to industry. So it's really exciting, not only because we're in the position to have such a huge impact on the safety and efficiency of air travel, but also because this is a very exciting technology. The ability to have truly global surveillance is revolutionary. And it's really once in a lifetime that you can have the opportunity to have such a big impact and a revolutionary impact on an industry. So this is the flight tracking system that we've implemented. And on the left side, you can see all of the data feeds that we bring in. So live data from ANSPs. We operate a ground-based ADS-B network where we develop the hardware and software and distribute ground stations. They're about this large. We have over 8,000 ground stations in 140 countries. And we fuse that with data link that we receive from ACARS, and coming soon, of course, the Aireon space-based ADS-B data, which will be truly global flight positions, and we anticipate that for the commercial applications, we'll be distributing those at the rate of about once per minute. By comparison, of course, although we are receiving for our SATCOM-equipped customers, which is a relatively small percentage of the world's airline fleet, we do receive position updates for them, but it's more like once every 15 minutes, and there are, of course, coverage limitations with a lot of the existing satellite constellations that airlines are using. Those limitations, for example, the North Pole, are becoming a larger, more significant problem as the range of airplanes continues to increase and there's a large increase in transpolar operations. So in the middle is our engine, our interpretive system. And what we do with that engine is we take in all of these messages, so thousands and tens of thousands of position updates and reroutes and amendments per second. And we evaluate each one of these for accuracy. And the challenge is that for a given flight at a given time, we're receiving a lot of different pieces of information about it, some which may be more or less accurate than each other. So multiple ANSPs may have radar observing a plane at one point. At the same time, we may have a ground-based ADS-B receiver that's receiving data. We're getting data link from the aircraft. We're getting data for reroutes from multiple facilities. And so we have to take all of these messages and score them and figure out what's the most accurate, then apply that to all the other information that we have. Where do we think the plane is going next? What is the route? What impact does this reroute have on the ETA, taxi time, arrival time, subsequent flights? And then we can leverage that data in a number of different ways. And we largely look to our customers and say, we have this information. It's the world's best source of information on where your planes are, where they're going, when they're going to arrive. And what tools do you need to help your operations, to ensure that you know where the plane is and if it's operating in a way that it is expected for you. So we have web interfaces, we can do email alerts, we can do text messages, we can do phone call outs. We have data feeds that are integrated into hundreds of different applications, whether it be crew scheduling, cargo scheduling, dispatch, billing, any range of applications, as well as different APIs for people to write their own applications, and then applications that we've developed, like Global Beacon, which we've announced with Aireon as a solution to the airline flight tracking challenges. This is our typical web interface that's available on our website, and the commercial version as well for aircraft operators. And this is a flight from Singapore to London. And our goal here is to abstract everything that we're doing and provide a simple interface to the end user, which in this case would be the aircraft operator, so that they know where the plane is. And they don't have to concern themselves with, is this aircraft SATCOM equipped? Is there a VHF ground station there? Does this ANSP provide data to FlightAware? We abstract all of that and we make a simple interface. And you can see what weather overlays, deviations the flight's taken around potentially turbulence or different airspaces and the route that it takes on this long haul flight. And this is truly revolutionary, what we've accomplished at this point. But of course, there's still gaps, and there's parts of the world that will never have ground-based ADS-B that will continue to have challenges for airlines that are looking to know far more frequently and far more reliably where their flights are. So what we've announced recently is a product called Global Beacon, and it's a joint product of FlightAware and Aireon, and we just announced as well our first customer, which is Qatar Airways, and they have a 100% ADS-B out equipped fleet of about 190 airplanes, and they're working with us to deploy this solution using Aireon's space-based ADS-B with our web interface and our alerting interface. And the goal here is for the airline to be able to know anywhere in the world exactly where the airplane is and have a platform to be able to define different alerting characteristics that they're concerned about. So different operators will have different requirements for when they're interested in knowing about a problem. And so what we're providing is a platform with a rule engine, and the operator can define when they want to be alerted and how. So in this example of a relatively simple configuration, the operator can say, I want a warning level alert when the airplane hasn't provided a position update in 300 seconds, and I want an emergency alert when there hasn't been an update in 600 seconds. And that allows us to have different types of alerting, whether the warning be maybe a pop-up on the screen on the web interface and maybe an email, and then emergency can be sending out text messages, placing phone calls. And this is of tremendous value because one of the challenges that our customers currently have prior to space-based ADS-B is when an airplane is not providing the position, is that airplane having a problem or is it out of coverage? And we've seen that with some of the tragedies in recent years where there's kind of this period of ambiguity where you don't know if an airplane is in distress or if it's just a generic coverage gap. So the value of truly global coverage, one of the biggest values is that you know anywhere in the world you should be getting one position update per minute. And what that allows airlines to do is get alerts and take action immediately. So if an airplane stops reporting position, whether it be a technical problem, whether it be some other sort of issue on the airplane that someone has intentionally stopped sending positions, the airline will know within minutes, not within hours, and they can immediately start to take action, which makes all sorts of intervention much, much easier. We can also detect and alert on things like different transponder codes. So there's the typical transponder codes that pilots use to indicate if there's been a hijack, if there is a loss of voice communication, or there's another emergency on board the flight. Those transponder codes are picked up by Aireon's ADS-B receivers, and we can alert on that instantly. So we're talking a matter of seconds before the airline knows that the pilot has indicated one of these distress conditions. There's all sorts of other valuable things that you can derive just by knowing where the airplane is, because we also know where it should be and its route. So for example, if it starts to descend and it's hundreds of miles from the destination, or if it goes off course, or if it starts to really slow down and it's nowhere near the destination, any of these can trigger an alert, and the airline can maybe send a ACARS text message to the cockpit, call the cockpit on sat phone, check in with ATC and say, hey, is there a reroute that we haven't received yet? And so the awareness that these operators have is really quite incredible compared to what they have now. And so we think this is going to have just a tremendous impact. The expectation of most regulations and most ANSPs for how they're going to implement these Gadis recommendations from ICAO is that by 2018, the operators need to know where the airplanes are on a 15-minute basis. And then in 2021, when there's a distress situation, either determined by the ground or in the air, that's a once per minute interval. The approach that Aireon and FlightAware have taken is, let's just give the operators once per minute all the time. And that's a benefit of the Aireon system, which is that there's no incremental cost to transmitting these position updates, because the airplane is just emitting these in a broadcast fashion using ADS-B. The Aireon has the data on the satellite. So we provide once per minute, well in excess of the 2018 requirement, and in compliance with the 2021 requirement all the time. It's also a little bit easier as well, because if you're trying to develop a system that is going to send position updates every 15 minutes and then detect a distress scenario and try and turn the position frequency up a little bit and have some ground-to-air interaction, there's a lot of complexity there, and you'd have to implement that complexity during a period of potential distress when there's a problem on the airplane. So having it be once per minute gets you ahead of the game before there's a problem, and you can know immediately. So it's a tremendous value. So this tool will not only provide airlines with a visual map of where other planes are, the ability to search and click on a specific plane to get all of the relevant details on where it is, where it's going, ETA, but a platform for creating any rule, a rule being a method of detecting a flight condition, whether it be distress or some other type of change, and knowing about it immediately. It's very exciting and going to have a tremendous impact on the industry. So that's what we've established at this point, and we're excited not only to provide this web interface, provide this rule engine for alerting, but also to provide the data to operators and to ANSPs and to search and rescue in any way that can benefit their normal flight conditions or an emergency scenario. So thank you very much, and I welcome any questions. Don is also available to answer them, whether it be about the Aireon space-based ADS-B constellation, the Iridium Next constellation, or the technology that we've jointly developed.